Okay, now let us look into this graph. This is local quality estimate graph. It helps us understand how confident we can be in the protein structure model. So here you will see two parts, residue number in x-axis and the predicted local similarity to target in y-axis. So residue number is just the position of each amino acid in the protein. Here 20 to 40 in this case, okay, 1 to 240. And this predicted local similarity target, this shows how similar the predicted protein structure is to a non-template. The higher the number, the more confident we are that the model is correct for that part of protein. And here the range goes from 0 to 1. 1 means very confident, and if the value is lower than 1 or near to 0, that means the model is not confident at all or have any issues. Okay, now look at these bars. Um, we have these blue colored bars and purple and red colored bars. Okay, these blue bars show areas where the model is very confident. The taller and more blue the bar, the more accurate that part of the model is. And these purple to red bars, these shows parts of the proteins where the model is not as confident. So if the bar is short and red, it means the model might be wrong or not very sure about that region. Okay, so when the bars are blue and tall, we can trust those parts of the protein model and it is of high confidence. And when the bars are purple or red, the model is less sure about that region and it have a low confidence. Okay, so this graph is a tool that helps us figure out which parts of the protein model are good and which one needs more working or more work on checking. Okay. Now we are moving to this structure assessment part. When we click on this option, uh, we can view our structure as well as the Ramachandran plot. This blue color indicates high confidence in our structure. And now uh, we are moving into this Ramachandran plot. Here the x-axis represent phi angle and the y-axis shows psi angle, the dihedral angles, and these green shaded areas are allowed regions where the dihedral angles means the phi and psi are more commonly found in stable protein structures. These dark green regions are highly favorable or most stable regions, and these light green are allowed region but less favorable. Okay, then these unshaded areas, they are disallowed regions where dihedral angles are very unlikely to occur due to steric hindrance or any atomic clashes. Now these points, each point represent a residue in the protein and its corresponding phi and psi angle. And these blue dots indicate residues that fall into allowed regions. And these red dots, these are outliers that may be potentially problematic or unusual. Okay, and from the plot, we can observe that most residues, that means the blue dots are fall into the allowed region, means the green zones, and that indicates the model structure aligns with the typical protein conformations. And this suggests the model is overall stable and well built. And these red colored outliers or residues outside the allowed regions might be errors in the model, or it represent any unusual or strain conformation in the protein. So this need a closer inspection to ensure they are biologically meaningful or need any adjustment. Okay, here in the bottom part, we have some options, and these options allow you to analyze specific type of residues. This general shows all residues, and this glycine. Glycine residues have greater flexibility due to the lack of a side chain, and may appear in less favorable region also. Okay, and now proline. Proline has a restricted flexibility due to its cyclic structure, so it will mostly occupy specific areas. And now pre-proline, these residues preceding a proline in the sequence, which have unique conformational preferences. Okay, so this Ramachandran plot suggests the protein model is well structured with most residues falling into favorable regions or this green shaded area. However, these red outliers should be further examined to confirm they are either biologically valid or indicate areas requiring any improvement in the model. Okay, that's all about this evaluation part and the Ramachandran plot. Thank you.